Hello, you guys. Welcome back to my channel. Today we're going to continue with dynamics. So grab yourself a piece of paper, a pen, and get your coffee, and let's dive in. Problem number 1. A 5-kilogram block on a 35-degree incline is acted upon by a horizontal force F equals to 200 Newton as shown. What is the acceleration of the block? Okay, so we have to calculate the acceleration. We're going to start by finding the formula, which is going to help us calculate the acceleration. And the basic formula is force, equals to ma. So from here, we know A is going to be equal to F divided by the mass. And we don't need any F, we need the F net, right? So this is not this force we're talking about. We need the net force. As you know, this block also has other forces acted on it. So we have to find out what is the net force. So let's start by finding out what are other forces acting on this block. As you know, let me draw the block here or redraw it here. This is the block. Okay, I'm going to show the force. This is the force F, which is 200 newtons. Then we have the weight. This block has a weight. Now, also there is the normal force, which acts perpendicular to the block and pulling up. This is the normal force. Great. One thing to point out is that the problem doesn't state if this block moves upwards or downwards. So we don't know which way it goes. We're going to have to figure that out. Let's start by choosing our coordinate system. I'm going to say this is X and this is Y. That being said, I'm going to have two components of the weight. This is going to be WY, and then this is going to be WX. Same thing with the force. Let me go back here, get the color. So this is going to be FY. And then here, this is FX. I will go here on the side and calculate all the forces. Let's see. I'm going to start with weight. So the weight equals to mg. The mass is 5 kilograms multiplied by gravitational acceleration, which is 981 meters over second squared. And this is going to give you the weight equals to 49 newtons. So now knowing the weight, we can calculate the x component of the weight and the y component of the weight. So Wx and Wy equals to, let's come here. I am going to show this is the angle theta. And also this is going to be angle theta here. And this is because this force is perpendicular to this line, and then this one is perpendicular to this line. That means this is also angle theta. Now let's see where else we have angle theta. We have this force is parallel to this line, and then this force is parallel to this line. So we also have angle theta in between these two forces. Okay, I'm gonna show it here, theta. Okay, let's find out Wx and Wy, x and y component of the weight. Since this is angle theta, Wy is going to be equal to W cosine theta. And Wx is going to be equal to the weight sine theta. Next, I'm going to calculate the force, the X and Y component of the force. Okay, so Fx and Fy. Okay, let's see. Fx is going to be equal to F. It's near the angle, so it's going to be cosine theta. And Fy is going to be equal to F sine theta. Perfect. Now that we have all the forces that act upon this object, we can do sum of forces in the X direction and find out which way this object goes. Sum of forces in the X direction equals to 0. This is going to give me Fx minus Wx equals to 0. And this results in Fx is F cosine theta minus Wx is W sine theta equals F cos theta is 200 cosine of 35 minus the weight is 49 sine 35 degrees equals. This is going to give you a force of 135.73 newtons. So we get this force of 135.73 newtons, which means that this force of 200 newtons does push the block upwards. If we would have gotten a negative force, it meant that the block goes downwards, because we considered positive on the right and negative on the left. Now, knowing that the block is going to move this direction, it means that we have a friction force that occurs in the opposite direction. So this is going to be friction force. I'm going to represent friction force over here. And this is friction force. Now that we found out which way this block goes, we have added the friction force, and now we have all the forces that are acting upon this object. So we are able to calculate F net. There is a relation in the FE handbook in order to find out the friction force. I'm going to go to dynamics, or I can just say, friction force. Let's see, it's over here. So friction force equals to mu multiplied by the normal force. So I can come here and calculate the friction force. It's going to be equal to mu. And in this case, since the object is moving, we are going to use the kinematic friction factor. If the object was stationary, we would have used ms. So mk multiplied by the normal force. But we don't know the normal force. Let's see, how can we find out the normal force? If I am to do sum of forces in the y direction equals to 0, this is going to mean that n normal force minus Fy minus Wy equals to 0. And from here, we can calculate n is equal to Fy plus Wy. And this equals to Fy is F sine theta plus Wy is W cosine theta equals F sine theta is 200 sine 35 plus 49 cosine of 35 equals 2. And this is going to give you a normal force of 154.9 newtons. Perfect. So now we have the normal force. We can come back here and calculate the friction force, which is going to be equal to 0.2 multiplied by 154.9. And you're going to get friction force equals to 30.9 newtons. Perfect. So we've got the friction force. It seems we have all of the forces to be able to calculate the net force. So net force in the x direction, let's see, F net. So F net is going to be equal to the sum of forces in the x direction. So we have Fx minus Wx minus friction force. And this is going to be equal, we have done this before, we have Fx minus Wx, this is 135.73, so 135.73 minus the friction force, which is 30.9, and this is going to give you a value of 104.83 newtons. So this is your net force. Now that we know the net force, we can come back to our initial formula and calculate for acceleration. I'm gonna come here and just delete this part. I'm gonna say A acceleration, say the results acceleration equals to 104.83 newtons divided by the mass, 5 kilograms. And this is going to give you an acceleration equal to 20.97 meters over seconds squared. And this is our correct answer. So we have found that the object is moving up, right, based on the fact that we have got a positive force here, and the acceleration is 20.97, which is approximately 21. So we're going to choose the option for upslope and 21 meters over seconds squared, option B. A mass m equal to 1 kilogram has a negligible size and is being swung in a vertical circular path, radius equal to 40 centimeters, using a string as shown. The angular velocity is 60 revolutions per minute. At the position shown, what is the tension in the string? We have mass equal to 1 kilogram. We have the radius equal to 40 centimeters. That is equal to 0.4 meters. And the angular velocity equals to 60 revolutions per minute. Here we're going to talk about what forces occur on an object that goes in a circular motion. In order for this object to remain in this circular position and not being thrown away, there's a force occurring that is pulling this object towards the center, and it's called the centripetal force. And I'm going to write centripetal force is going to be equal, again, we're going to use MA formula, but this A, since it's going in a circular motion, this is going to be equal to AR, which, coming to the FE handbook, let me go to the circular motion. There you go. We have acceleration towards the center of the circle is AR, which is R omega squared. So this is also going to be equal to M R, oh, excuse me, R omega squared. The centripetal force in this case is given by the tension in the string. So this is tension and it's pulling towards the center. At the same time, we have this mass is W is equal to 1 kilogram. Let me calculate weight equals to 1 kilogram multiplied by G, it's mg. Let me write that down. Okay, mg, and this is going to equal to 1 kilogram multiplied by 981 meters over second square. And this is going to be equal to 981 newtons. Great. So we have the weight equals to, this is not 1 kilogram, equals to 981 newtons. Perfect. I'm going to choose the coordinate system. This is going to be X and this is going to be Y. So this is going to be WY and this is going to be WX. And this angle is 45 degrees. This is going to be an isosceles triangle. This is also going to be 45 degrees angle. So now we can say, based on this, that FC, centripetal force, is going to be equal to the tension in the string plus WX. So now let's substitute. We're going to have mass R omega squared is equal to tension in the string, which we don't know, we have to calculate, plus WX, which is weight cosine 45 degrees. So now from this equation, we can calculate for T. T is going to be equal to M R omega squared minus weight cosine 45 degrees. Now let's substitute. I'm going to come back on the other side, say T is equal to, mass is 1 kilogram multiplied by R, which is 0.4 meters, multiplied by omega squared. Now, omega is given in the revolutions per minute. Let me come here. We're going to have to transform revolutions per minute into radians per second. Remember how much is one revolution? One revolution is actually 2 pi. It's one complete circle. So in order to transform revolutions into radians, we are going to say that one revolution equals to 2 pi radians. And be careful to have your calculators set for radians when you do this calculation. Okay, and then 1 minute is equal to 60 seconds. So now we're going to get rid of minute with minute, and revolution with revolution is going to go away. And look at that, 60 and 60 go away. So we have 2 pi, and let me put my calculator into radian mode. There you go. So I can do this calculation now. 2 pi multiply gives me an omega equal to 6.28. And these are radians per second. So coming back here to my problem, I'm going to add omega squared, which is going to be equal to 6.28 radians per second squared minus weight, which is 981 newtons, multiplied by cosine 45, which is square root of 2/2. Okay, now doing all of these calculations, you should get that the tension in the string is going to be equal to 8 6.84 newtons. And this is the correct answer. 884. The correct answer is B. Now let's move on to the next problem. A pulley system consisting of a fixed and movable pulley is loaded as shown. If the pulleys are assumed to be massless and frictionless, what is the vertical acceleration of the 60 kilogram mass? It's a very important note to make that the pulleys are massless and frictionless. This means that the tension in the spring is going to be constant everywhere. We're going to have T here. We're going to have T on the other side as well. Looking at what we're asked, so the acceleration, we have to calculate acceleration. All day today is calculating acceleration. The formula for acceleration is F equals to ma. And again, we're going to make this even better. Let me write down net, F net. So I'm going to say, go back here, F net equals to mass times acceleration. Perfect. Let's draw the free body diagram for the 20 kilogram mass, and then we're going to do the same for the 60 kilogram mass. So here under the force, I'm going to have the block, and I will show the forces that occur. So this block has a weight pulling downwards, and then the tension in the spring is going to pull upwards. This is T. So these are the forces that occur upon this 20 kilogram block. And this is equal to, let's represent this part. We're going to have mass of this is 20 kilogram. This 60 kilogram block is going to pull the entire thing in this direction. So it's going to accelerate downwards, which means this 20 kilogram block is going to accelerate here upward. Right? This is going to accelerate in this direction because this 60 kilogram mass is going to pull this downwards. So we have acceleration pulling upward. So if we want to now write the equation, we're going to say, let's say this W1, because this is a 20 kilogram block. So the equation for this is going to look T minus W1. This represents the forces. T minus W1, the net force, as we've mentioned here, equals to ma, which is 20 multiplied by acceleration. So we have our first equation. Next, let's take the 60 kilogram block. Again, let me change the color. So I'll have the 60 kilogram block. And again, I'm going to say these are the forces equal to mass acceleration. So now looking at the 60 kilogram block, we have the weight pulling downwards, again, which is weight 2, I'm going to say. And then upwards, we have 2 tension strings pulling upwards. So this is T and this is T. These are the forces, and this is equal to, let's represent this other side, ma, which is 60 kilograms. And now let's talk about the acceleration. Since in the first case, the acceleration was going upward, we have 1 tension spring. In this case, we have the acceleration is going to go downwards because this 60 kilograms is going to pull the whole system downwards. So it's going to accelerate downwards. Okay. And since we have 2 tension strings, this is going to be equal to half of the acceleration in this case. So A over 2. Let's write the equation for this system now. We're going to have, so everything's going to go downwards now. We're going to have W2 minus 2T is equal to 60 A over 2. So this is our second equation. We have two equations and we have two unknowns. We have tension in the string and acceleration. Let's start by calculating the weight 1 and weight 2. So weight 1 is going to be equal to mg, which is 20 multiplied by 981. And this is going to be 196.2 newtons. Same here. G is equal to 60 multiplied by 981. And this is going to be equal to 588.6 newtons. Great. We have W1, W2. We can come here and calculate T from one equation and then substitute it in the next equation. Let's do that. We're going to say here T from this equation is going to be equal to 20A plus W1. So now with this, we can come back here and substitute. We're going to have W2 minus 2 multiplied by 20A plus W1 equals 2. Here we can reduce. We have 31. So it's going to be equal to 30A. Now let's open the parentheses there. We're going to have W2 minus 40A minus 2W1 equals to 30A. So we have A here one time, here one time. This is going to be 70A if we take this member on the other side. 70A, it's going to be equal to W2 minus 2W1. And A is going to be equal to W2 minus 2W1 over 70. Now let's go ahead and substitute here. A is equal to W2 is 588.6 minus 2 multiplied by 196.2 divided by 70. And I get an acceleration of 2.81 meters over second squared. And now, if we were asked in the problem, what is the tension in a string, we would just come back here, this equation, substitute acceleration, and find out for tension in the string. We're not asked that, so we stop here. Acceleration is 2.81. The correct answer is D. Perfect. Moving forward. Another pulley problem, a fixed pulley having radius 100 millimeters and mass 10 kilograms, supports a smooth cable which supports two masses of 20 kilograms and 60 kilograms as shown in the figure below. What is the acceleration of the 60 kilogram mass? So it seems they are kind of similar, but we have this information here, the mass of the pulley, which means that the tension in the string is going to be different. We're going to have T1 and we're going to have T2 on the other side. We're also again asked the acceleration. We're going to start by laying down F net equals to MA, from which A is going to equal to F net divided by mass. Let's do the same thing that we did on the other side and draw the body diagram for the 20 kilogram mass, the body diagram for the pulley because it has a mass now, and for the 60 kilogram mass. let's just make a note that since this is heavier, this block is heavier, the whole system is going to accelerate in this direction. So for the 20 kilogram mass, it's going to go, tension is going to go upwards. This is going to be T1, and then we have weight of this, let's say weight 1. So these are the forces equals to MA. Let's represent now the MA part. This is 20 kilograms, and acceleration is going to go upward. So if we want to write the equation for this system, we're going to have the forces, the F net, which is T1 minus W1 equals to 20A. Next, let's represent the 60 kilogram mass, 60 kilogram mass, which is going to have W2, and the tension is going to pull upwards, and we're going to have here T2. I'm going to repeat the fact that we have different tensions on both sides of the pulley because the pulley now has a mass, so the tension is different. So this is T2. So we have represented the forces. It's going to be equal to, let's say, MA. We're going to represent the MA side now. This is 60 kilograms. And the acceleration, as we have talked, it's going to go downwards. And since we have only one tension going up, this is going to be equal to A. And previously, if you remember, we had A over 2 because we had 2 tension pulling upwards. Here we have only one, so it's going to be equal to A. The same thing let's do, and let's represent the forces for the pulley. We have T1 pulling down. We have T2 pulling downwards on this side. This is R. So for dynamic equilibrium, for rotation about some arbitrary fixed axis, this is the equation for dynamic equilibrium. So I'm going to write this down. In this case, we had F equals to MA, F equals to MA. Now we're going to have that M is equal to I multiplied by alpha, where I is the mass moment of inertia and alpha is the angular acceleration. So let's write this part by taking the moment by this point. Since the whole system is going to go, it's going to rotate in this direction, we're going to have this direction positive. So I will say T2 multiplied by R. This is the positive part. Now, this tension pulls on the other side due to the 20 kilograms. So it's going to be minus T1 multiplied by R equals 2. And then we have this part, I alpha. Let's see, what is the mass moment of inertia of this pulley? And you can find out by going to the dynamics all the way at the end. I'm going to go to materials, and if you go up a little bit, this is dynamics. We have a thin circular disc. This is the shape of our pulley. And the mass moment of inertia is going to be equal to 1 over 2 multiplied by mr squared. Let me write that down. 1 over 2 multiplied m, which is the mass of the pulley, multiplied by r squared, which is the radius. You know, the radius, I'm going to represent it the way I have already shown it here as r squared. Great. And then alpha is the angular acceleration. Let's go in the handbook. I'll do a search for angular acceleration. Let's find the formula for alpha that is dependent upon, there you go, acceleration equals to r alpha, and alpha from this equation is going to be equal to acceleration over r. Acceleration over r. So coming back to this equation, we can write down that T2 multiplied by r minus T1 multiplied by R equals 2, and we have mass moment of inertia 1/2 m multiplied by R squared multiplied by alpha, which is A over R. R with R goes away, and then we have all of these R's that also go away, and we can rewrite this equation as T2 minus T1 equals 2 m A over 2. I'm just looking here at those formulas, and I have m here and m there. So this is the moment. So let me try and maybe say m, I don't know, m torque. I'm just call it mt. mt, which is T2R minus T1R. And this represents the mass of the pulley. Just I don't want you get confused. This is the mass of the pulley. This is not the moment, it's mass of the pulley. Okay, let's move on. So I have not written this equation here. Look at me, I just left it blank. So this is going to be, let's see, this is the 60 kilogram with mass going downwards. I'm going to have W2 minus T2 equals 260 A. There you go. We have three equations. We have equation number 1, equation number 2, equation number 3, and then we have three unknowns, T1, T2, and the acceleration, which means we can find out our acceleration. Let's see, we can calculate T1 from this formula, T2 from this formula over here, and then substitute it in this formula and calculate for acceleration. All right, so I'll do, let me see, maybe I should delete something. I'm going to delete this part here at the top so I can do my calculations. There you go. Let me just delete everything. Okay, so from this equation, I'll say T1 minus W1 equals to 20A. And then I'll have the next equation, which is W2 minus T2 equals to 60A. And the next equation is T2 minus T1 equals to mass of pulley multiplied by acceleration over 2. So this is our system. And I'm going to go ahead and delete the rest so I can calculate for the unknowns. Equation number 1, let's calculate for T1 is equal to 20A plus W1. Equation number 2, we're going to calculate for T2 is equal to W2 minus 60A. And now we can substitute everything we know in this last equation. So T2, it's going to be equal to W2 minus 60A minus, and then we have T1 minus 20A minus W1 equals to MA over 2. Now, let's move all the members that have acceleration on one side. So I will get, moving forward, let's say results, W2 minus W1 equals to MA over 2 plus 60A plus 20A. Now we can go and substitute. I'll try and I make a little bit more room. Let me delete this part as well. Say W1 is equal to mg, which we have calculated 20 times 981, 196.2 newtons. W2 is equal to 60 multiplied times 981 and gives you a value of 588.6 newtons. Now let's substitute. We have W2, which is 588.6 minus W1, 196.2 equals to M. M, which is mass of the pulley, is 10 kilograms multiplied by A over 2 plus 60A plus 20A. This results, this difference over here is equal to 392.4 equals to 85A. And from here, A is equal to 392.4 divided by 85. And this gives you a value for acceleration of 4.62 meters over seconds squared. This is the acceleration of the system. So the correct answer is C. One thing that I would suggest you do to kind of train yourself of solving this kind of problems is assume that this pulley is massless and frictionless. So ignore this part and just solve this problem just the way we did the previous problem, just to get used to these calculations. Now let's move on to the next problem. A force F of short duration acts on a stationary mass M equals to 1.6 kilograms. The profile of force F is shown in the figure below. What is the velocity of the mass at t equal to 0.05 seconds? This is an impulse and momentum problem. Let's go to the FE handbook and I will write impulse and momentum. And you are given formulas for impulse and momentum. The short definition of momentum is mass in motion, because momentum equals to mass multiplied by velocity, mdv, or change in velocity. And the impulse is equal to the force multiplied by t, or the force multiplied by change in time. Let's write these two formula down. I'm going to write that the impulse is equal to force multiplied by dt, or multiplied by t, and formula for momentum equals to mass multiplied by velocity. Let's see what are the units for the impulse. We have force, which is newtons, multiplied by t, which is seconds, and then in this case we have mass, which is kilograms, multiplied by meters over seconds. So if we move forward, we know newtons equal to kilograms multiplied by mass over seconds squared, and then multiplied by seconds gives me a unit, kilograms multiplied by mass over seconds, which is similar to these units. That's why here in the FE handbook, these two are equal. Based on the FE handbook, this is called impulse momentum theory. In the FE handbook, you're given that m multiplied by change in velocity, which is the momentum, equals to force multiplied by change in time. And this is called the impulse momentum theory. Okay. So let's see now how we are going to solve this problem. We have this graph and we have force and time, which is giving you the impulse. The impulse can be calculated based on this graph, and it's going to be the area underneath this curve, the area of the triangle, which is 1/2 multiplied by, we have 4 kilonewtons. If we were to transform it in newtons, I'm going to have 4,000 newtons multiplied by 0.05. There you go. This gives me an impulse equals to 100 Newton second. Perfect. Now, if I was to come here and say that this equals to mdv, based on this impulse momentum theory, we know that impulse equals to the momentum. So I will say that mdv equals to 100 newtons. And moving forward, m equals to 1.6 kilograms. So 1.6 kilograms multiplied by dv, change in velocity. So it's v final minus v zero. The problem states that the mass is stationary at t equals to 0. So v0 equals to 0. And this equals to 100 Newton seconds. 100 Newton seconds. Here, I forgot to add seconds. Now let's rewrite this. We're going to have 1.6 multiplied by v final equals to 100. And from this equation, we can calculate for VF. From here, VF equals to 100 divided by 1.6. And this gives me a velocity of 62.5 meters per second. There you go. So the correct answer is B. Next problem, 2 billiard balls, different masses, collide on a horizontal table after traveling along the dashed lines as shown. Velocities just before impact are indicated on the diagram. If the coefficient of restitution is 0.8, how much of the initial kinetic energy is lost due to the impact? The problem is asking for kinetic energy that is lost due to impact. Kinetic energy lost. And it's asking us in percentage, the percentage of this kinetic energy. Let me delete this little line here. There you go. Okay, so let's focus here. We have the velocities before the impact, and then we have to calculate after the impact. We have the coefficient of restitution. Let's come back to the FE handbook and, oh, we're just going to use this. V1 prime, V2 prime, we're going to calculate the velocities. The formula for kinetic energy is equal to mv squared over 2. Now we have m, we have masses, we have velocities before impact. So we can calculate the kinetic energy before impact. What we need to find out, what are the velocities after the impact? So we have kinetic energy before impact, and then we need to calculate the kinetic energy after the impact, which is going to be equal to mv prime squared over 2. And then in order to calculate the kinetic energy lost, we're going to subtract before and after, and whatever is left, that's going to be the lost. So what we're going to do, we're going to say kinetic energy before impact minus kinetic energy after the impact equals to kinetic energy lost. So first, let's calculate the velocities after impact. Let me delete this here. And we have the formula for that. Oh, there you go. The velocities after the impact while knowing the coefficient of restitution E, which is what we know. Let's write the formulas down. I'm going to come over here and say that VA prime, I'm going to start with VA prime equals to MB multiplied by VB multiplied by 1 plus E plus, and the only thing I did in the FE handbook, we have M1, V1, and V2. I just substituted with A and B. So here you've got MA minus E MB multiplied by VA. And everything divided by M1 plus M2. This equals to, we have MB as 200 grams multiplied by VB. VB is again positive, so we have plus 20 because it goes in the right side, and VA is going to be negative, goes on the left side. So VB is positive, we're going to multiply by 20, and then multiply by 1 plus 0.8 is the coefficient of restitution, plus MA, which is 170 grams, minus 0.8 multiplied by MB, which is 200, and multiplied by VA, which is minus 12. All divided by 200. See, I did MM2. I'm going to have to do A and B just to be consistent. And here we have 170 plus 200. Calculating all this, you're going to get VA prime equals to 19.14 meters over seconds. And the same, let's calculate VB prime equals to, the formula in the FE handbook, I have MA multiplied by VA, 1 plus E minus EMA minus MB multiplied by VB, and everything divided by MA plus MB. Now let's substitute, and we're going to have MA as 170 multiplied by VA minus 12. Don't forget the minus sign. 1 plus 0.8 minus 0.8 multiplied by MA, which is 170, minus MB, which is 200, multiplied by 20, which is VB, everything divided by 170 plus 200. And if you calculate this, you should get a value of minus 6.46 meters per second. So I'll write down here VB equals to, VB prime equals to minus 6.46 meters per second. So the only thing we did, we just took the formulas from the FE handbook and substituted everything we know. I think I'm just going to delete this part because I have to calculate kinetic energies. I'm going to write VA prime. Let me do this in a different color. So I'll have VA prime equals to 19.14 meters per second, and VB prime equals to minus 46 meters per second. And the minus shows us the fact that it points out to the left. After the impact, velocity for B is towards the left. So let me delete the rest. I don't need this anymore. Great. Okay. Now let's calculate the kinetic energy before the impact. So we have talked about the fact that the formula for kinetic energy is mv squared over 2. So the kinetic energy before impact, we're going to have m1 multiplied by, or ma multiplied by va over 2 plus mb multiplied, this is squared, vb squared over 2. And this is going to be ma equals to 170 grams. If we divide by 1,000, we're going to get kilograms. And I'm going to work in kilograms here, 0.17 multiplied by VA squared, which is going to be 12 squared divided by 2, plus MB is 200 grams, is going to be 0.2 kilograms multiplied by VB, which is 20 squared divided by 2. And this is going to give you a kinetic energy before impact of 52.24. And the units for kinetic energy is joules. And now let's calculate kinetic energy after the impact. And we're going to use the same formulas. We're going to have MA multiplied by VA prime squared over 2 plus MB multiplied by VB prime squared over 2 equals 2. Again, 0.17 multiplied by VA prime squared. I have 19.14 squared over 2 plus MB 0.2 multiplied by velocity of 646 squared over 2. And this is going to give you a kinetic energy after the impact of 35.31 joules. And now we have to take the difference of these two. So the kinetic energy that is lost is going to be equal to 52.24 minus 35.31. And this gives you a value of 16.93 joules. So 16.93 joules is lost after the impact. Now we have to calculate this in percentage. So the easiest way to do this, if before the impact we have 52.24, that is the total kinetic energy. So 52.24 represents 100% of the kinetic energy. Now 1693, we don't know how much percentage that represents. So from here, X is going to be equal to 16.93 multiplied by 100 divided by 52.24. And this gives you value for X of 32.4%. So this is how much of kinetic energy is lost after the impact. 32% is option B. And that's how you solve a problem like this. That's all I have for you today, my friends. I hope you found this video helpful. If you did, don't forget to subscribe and give it a like. Keep up the good work on practicing as many FE problems as you can, and I will see you next week.